let's look at some more aspects of gamma function. Gamma of n is equal to the lambda to the power of n times the integral 0 to infinity of t to the power of n minus 1 times e to the power of minus lambda t dt. So this is another identity that we are looking at. Let's see how we can prove this. By definition, gamma of n is equal to the integral from 0 to infinity of x to the power of n minus 1 times e to the power of minus x dx. So let's do substitution. X is equal to lambda t, which implies dx is equal to lambda dt. Now, taking care of the limits, we have when x goes to 0 or when x equal to 0, t equal to 0. When x equal to infinity, t equal to infinity. Or rather, we should say, as x goes to infinity, t goes to infinity. Okay, so gamma of n is equal to the integral from 0 to infinity, since the limits don't change, of x to the power of n minus 1. X is lambda t. So lambda t to the power of n minus 1 times e to the power of minus x. So e to the power of minus lambda t times dx, that is lambda dt. Simplifying this or splitting this, we have lambda to the power of n. How? Because here you have lambda to the power of n minus 1 and here you have lambda. So n minus 1 plus 1 gives us n. So lambda to the power of n times t to the power of n minus 1 times e to the power of minus lambda t dt. Now lambda to the power of n is a constant. So it comes out of the integral. So we have gamma of n is equal to lambda to the power of n times the integral 0 to infinity of t to the power of n minus 1 times e to the power of minus lambda t dt, which is what we had to show. So we have another identity here. Okay, now let's look at another one. Gamma of n is equal to the integral 0 to 1 of natural log to the power of n minus 1 of 1 by y dy. Again, we start with the definition. Gamma of n is equal to integral from 0 to infinity of x to the power of n minus 1 times e to the power of minus x dx. So here let x is equal to natural log of 1 by y. Then e to the power of x is equal to e to the power of natural log of 1 by y, which is equal to 1 by y. What have we done here? We have exponentiated both sides. So e to the power of x and e to the power of natural log of 1 by y. Now e and natural log cancel out to be left with 1 by y, which means y is equal to e to the power of minus x. Okay. And now differentiating this, we get dy is equal to minus e to the power of minus x dx. So here we are differentiating with respect to x, which implies dx is equal to minus dy by y. Because dx is equal to dy by minus e to the power of minus x, and e to the power of minus x is y. Again, taking care of the limits, when x equal to 0, e to the power of 0 it becomes. So y is equal to 1. When x goes to infinity, what happens? Y is equal to 0, because e to the power of minus infinity is 1 by e to the power of infinity, which is 0. So now carrying out the substitution, we get gamma of n is equal to the integral from 1 to 0 of x to the power of n minus 1, which is x is natural log of 1 by y to the power of n minus 1 times e to the power of minus x. E to the power of minus x is y times dx. Dx is minus dy by y. Now simplifying this, what happens? This y and y cancel out. This minus we can make it disappear by exchanging the limits. So we have gamma of n is equal to the integral from 0 to 1 of natural log to the power of n minus 1 of 1 by y dy, which is what we had to show. So another identity we have. Now let's look at another one. Gamma of n plus 1 is equal to n times gamma of n, which we have already seen, which is in turn equal to 1 by n times the integral from 0 to infinity of t to the power of 1 by n times e to the power of minus t to the power of 1 by n dt, where n is greater than 0. Again, we start with the definition. By definition, gamma of n plus 1. Now, instead of starting with gamma of n, we are starting with gamma of n plus 1 is equal to the integral from 0 to infinity of x to the power of n times e to the power of minus x dx. Now here let t is equal to x to the power of n, which means x is equal to t to the power of 1 by n. And differentiating it, we get dx is equal to 1 by n times t to the power of 1 by n minus 1 dt. So here we are differentiating x with respect to t. Again, changing the limits. When x equal to 0, t is equal to 0. When x goes to infinity, t goes to infinity. So here, gamma of n plus 1, we are going to carry out the substitution. Integral from 0 to infinity of x to the power of n is t. So t times e to the power of minus x. E to the power of minus x is e to the power of minus t to the power of 1 by n times dx is 1 by n times t to the power of 1 by n minus 1 dt. Let's carry out the simplification. Here we have t to the power of 1. So 1 plus 1 by n minus 1, which gives us t to the power of 1 by n. E to the power of minus t to the power of 1 by n remains as it is. Dt remains as it is. 1 by n is a constant, so we take it out of the integral. So we have arrived at what we started off to prove, that gamma of n plus 1 is equal to 1 by n times the integral 0 to infinity of t to the power of 1 by n times e to the power of minus t to the power of 1 by n dt. And since gamma of n plus 1 is equal to n times gamma of n, we have n times gamma of n also equal to this integral. So that is another identity that we have. Now let's look at some concrete examples. Integral from 0 to infinity of x cube times e to the power of minus x dx. Pretty straightforward. If we look at the definition, we have to write x cube in terms of n to the power of n minus 1. So we have integral from 0 to infinity of x to the power of 4 minus 1 times e to the power of minus x dx. So which means gamma of 4, or we could have directly gone to gamma of n plus 1 should be equal to 3. So gamma of 4 is equal to gamma of 3 plus 1, which is equal to 3 factorial, which is equal to 6. So look at these identities and understand this. Now let's look at another one. Integral from 0 to infinity of x to the power of 3 by 2 times e to the power of minus 4x dx. Carry out the substitution. T is equal to 4x, which implies dx is equal to dt by 4, and t is equal to 4x also means x is equal to t by 4. So carrying out the substitution, we get integral from 0 to infinity of x is t by 4. So t by 4 to the power of 3 by 2 times e to the power of minus 4x. 4x is t. So e to the power of minus t dx is dt by 4. Simplifying this, we get integral from 0 to infinity of t to the power of 3 by 2 divided by 8. So here 4 cube we take. 4 cube is 4, 4, 16, 464. Square root of that is 8 times e to the power of minus t dt by 4. So here 8 times 4 is 32. 1 by 32 comes out of the integral times the integral 0 to infinity of t to the power of 3 by 2 times e to the power of minus t dt, which is equal to 1 by 32 times the integral 0 to infinity of, now 3 by 2 we write it as 5 by 2 minus 1. So we have t to the power of 5 by 2 minus 1 times e to the power of minus t dt. So this can be written as gamma of 5 by 2. So we have 1 by 32 times the gamma of 5 by 2. And gamma of 5 by 2 can be written as 3 by 2 times 1 by 2 times gamma of 1 by 2. Gamma of 1 by 2 we know is root pi. So we have 3 root pi divided by 32 to 64 to 128. Now instead of doing all this, what we could have done, we could have just taken n minus 1, because we require, as part of the standard definition, x to the power of n minus 1 should be equal to 3 by 2, which means n equal to 5 by 2. E to the power of minus 4x is of the form e to the power of minus lambda x. And we already have a identity for that. So here 4 is the lambda and we need lambda to the power of n. So 4 to the power of 5 by 2 is equal to 2 to the power of 5, which is 32. And here in this identity, if you look, lambda to the power of n can be taken to the denominator on the other side. So we have 1 by 32 times gamma of 5 by 2 is equal to this integral. Now the rest of the steps are same. So we could have avoided all this substitution business. And these steps, we can actually do it in our mind itself. Here I have just mentioned it for clarity's sake. That was another set of identities and some concrete examples. If you found this helpful, don't forget to like, share, and subscribe. Questions, suggestions, and comments are always welcome. Thanks for watching. See you in the next session. That's it for now. Bye.